Welcome back. In this section, we are going to learn few important Kubernetes concepts which are required for our application deployments on the Kubernetes clusters. Okay. So in our previous lectures, we have implemented all these things like a MySQL deployment where we have the MySQL database, and for that we have mounted the persistent storage of Elastic Block Store from AWS with all these Kubernetes concepts like storage classes, persistent volume claim, config maps, deployments, environmental variables, volumes, volume mounts, all these things. Okay. So now what we are going to do is we have completed the underlying part here, but we also need to focus on our application we are deploying here, right? So first thing is secrets. So whatever the DB password, whatever we have provided for this application, why can't we send it in the encrypted format? Okay. So for that purpose, we are going to use secrets. The same we can apply for the MySQL root password environmental variable in deployment. So the next thing is initialization containers. So these are nothing but we have seen one issue related to before the MySQL container started, the application got started and then one more time it restarted. It didn't wait for the MySQL service to come up. So to ensure that MySQL container to come up and then start the application, we can implement initialization containers. So in addition to that, we can implement the Liveness and then Readiness probes of our application so that the traffic can be allowed to this respective pod only once the Liveness and then Readiness probes are successful. So those we need to implement for our application. In addition to that, we can even implement requests and limits for our application pods, which means how much CPU, how much memory in the Kubernetes cluster our respective application pod should be taking. We can request those things and then also put a hard limit for that using limits. In addition to that, so if we have multiple versions of our application, or if we want to deploy in the same EKS cluster, you have staging and then development and then QA environments. So you can even create namespaces separately for dev, QA, staging, and then deploy the same application and then same version inside those separate namespaces. Okay. So like this, you can use namespaces to differentiate your environments or in various regions, or even for namespaces like you can allocate for dev environment, my Kubernetes cluster, this much resources only should be allocated for this namespace, this much CPU and then this much memory. So all those things we can implement, and those are very important for the applications we are going to deploy on Kubernetes cluster. So these things we are going to implement now. So if you go here in 05, Kubernetes important concepts for application deployments. Okay. So we are going to look into Kubernetes secrets, initialization containers, liveness and readiness probes, and requests and limits, and then namespaces in 5 sections now. Okay. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. So let's go ahead and then implement the Kubernetes secrets for our application and the database. Okay. So Kubernetes secrets let us store and manage sensitive information such as passwords or OAuth tokens or SSH keys in a base64 encoded format. So storing confidential information in a secret is a safer and more flexible way instead of putting them directly like DB password 11 or whatever in the application manifest, deployment manifest, or even the database related deployment manifest. Okay. So what we are going to do is we are going to create a secret for our MySQL DB password. Okay. So if you have base64 installed on your Mac machine or on your Linux machine, so my DB password is DB password 11. Okay. So you can directly run this here. Okay. And then get the secret and then update in your respective secrets file. So like this, or you can go to this URL base64encode.org and then provide your DB password 11 here in the encode to base64 format, and then click on encode, and then you will get the value. So both are going to be same anyway, but based on your, if you are using Windows and then you don't have base64 installed on your Windows machine, so you can use base64encode.org also. So now we'll go ahead and then create the Kubernetes secrets manifest. Okay. So if we go to this one, right? So our Visual Studio Code editor. So in 05 Kubernetes important concepts, you can see 0501 Kubernetes secrets. So there in our previous lecture, whatever we have created, which is nothing but in 0403, right? So all those manifests we have brought here, which is nothing but all the 7 manifests, whatever we have created, we have brought here. And then we are going to live edit them by creating the Kubernetes secrets file first. Okay. So as usual, so I have put the Kubernetes standard template here, which is nothing but API version, kind, metadata, and then spec. So the kind is going to be secret, and the API version is from core, it is v1. And now the metadata, the name of the secret here, right? So in metadata, usually we will have name and then labels, right? So we'll give name, that will be sufficient for us. So I'm going to say MySQL DB password will be the name of my secret. Okay. And instead of spec, usually this will have something called data. Okay. So like how the config map we create with data, right? It is the same thing. In addition to that, there will be one more top level object called type, and type we need to provide opaque, because ours is a unstructured content, which means like key value pairs. So we'll show what is that key value pairs now. So opaque means Kubernetes point of view, the contents of the secret are going to be unstructured. Okay, so let's see what does that mean. Okay, so you can give, so under data, so you can give the key value pairs whatever you want. So I'm providing one key value pair here, and we can get whatever we have generated here. Okay, so this is the password, right? I'm saying DB password, and whatever we have generated for DB password 11, the base64 format, I have pasted here. So if you have something, even if you want to encode DB username, you can provide, or if you want to DB host, if you want to put, so you can even put DB host. So like this, how many features, how many you want to put, that many you can put in key value pair. So that's the unstructured way of putting it. So that's the reason we have provided the type opaque. Okay, so now I have provided DB password with DB password 11, which is in base64 format. So now we have completed the Kubernetes secrets file creation here. Okay, so now let's go ahead and then update our MySQL deployment. In our MySQL deployment, if you see here in the environments, you have name is MySQL root password and the value is DB password 11. So instead of value directly taking it here, you can do one thing for this. Okay, so let's remove this and say that value from. Okay, so we are getting the value from secrets. Okay, and from where you are getting, it is getting from the secret key reference. Okay, so secret key ref is the tag here. Okay, so and you need to provide your 2 objects here. Okay, so 2 attributes. Okay, so name and the key, right? So from which secret it is going to bring the value? So from MySQL -db- password, the name of your secret. So whatever you have provided here, the name of the secret. So this becomes the name and this becomes the key. So from which key it need to fetch is DB password key it need to fetch. So let's go to MySQL deployment and paste it here. That's all. Okay, so value from secret key reference and name is MySQL -db- password and the key is DB password. So now the MySQL root password will be DB password 11 in this manner. So the same way we can implement the same for our user management microservice deployment. Okay, for this DB password. Okay, so as usual, one more time. So we'll say value from, right? And I will say secret, under that the child object is secret key reference. Okay, and we'll have 2 child objects here, name and then key under secret key reference, and the name is going to be MySQL -db- password and the key is going to be DB password. Okay, so now we have updated wherever we have the password in our application, we have updated with the secret whatever we have created. Okay, so now we can go ahead and then implement, means like we can run the stuff. Okay, so which is nothing but we can run the Kubernetes manifest here, means like apply or create the manifest and then see what happens. So create all the objects and then test it. So let's go here, and if you see there are nothing running in my application cluster now. So what I'm going to say is, so I am in the 0501 Kubernetes secrets folder. So I'll say ls and then you'll find only kube manifest, and if I go there inside that you can find 08 secrets. So I'll come back out of kube manifest. I'll say clear, and I'll say kubectl apply -f and kube manifest. So now I should have everything get created, which is nothing but my secrets, and then everything will get created. Okay, so now everything got created. So now let's see what happens. Okay, so kubectl get pods. Okay, and this container is getting created, and this, as usual, the user management container already started and running, which might fail and then restart because MySQL is not ready. So this issue still exists, and in our next section, which is initialization containers, we are going to fix it. Okay, so see, one time restart happened, that's fine. Okay, so now everything is up and running. So mostly, so kubectl logs, and then if the DB password is wrong, then obviously this will not come up in running state, right? We'll have issue. So we'll see that user management came up successfully or not. Okay, so it's coming up. Let's wait for it to initialize and then see. Okay, so if it initializes properly and says that started user management service, okay, see, started user management. So my DB password, whatever I encrypted, and then whatever how we have implemented using secrets, everything is working fine. Using this thing, we can ensure that it is, we can ensure that it has worked. Okay, so now Control C, and then if we want, we can go to our browser, and then as usual call it, the cluster IP is going to be same, and then health is same, so it is going to work. Or if we want to go to Postman and then list all users, and then see, it's going to be nothing. Okay, so why? Because we have recreated the stuff, everything. Right now entire thing we have deleted and then recreated, which means like entire all the storage classes and then PVC, everything we have deleted from previous section and created. Nothing you can see here. Okay, so health status, you can see it's 200. In the same way, if you want to create the user one more time, you can create the user and go to list users, and then you got the user. That's all. Okay, so this completes the secrets section. So what we need to do is, as we have completed this, we'll go ahead and then delete all this stuff whatever we have created. In our next section, again we are going to create it and then see that how our initialization containers solved our issue. So let me remove everything. So we have deleted everything. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about Kubernetes init containers and then implement them. So let's get into 0502 init containers, right? So before going and then implementing them, let's understand what are these init containers on a very high level. Okay, so init containers usually run before the app containers inside the pod. So init containers can contain utilities or setup scripts not present in the core app image, and then they can run before the app container runs. So we can have and then run multiple init containers before the app container starts. Okay, so init containers are exactly like regular containers, except init containers always run to the completion. In addition to that, each init container must complete successfully before the next one starts. So if we have multiple init containers, one after the other, each need to execute the task assigned to that container and then complete it, and the next one starts and then complete it. Finally, all the init containers are succeeded, then only the app container will start. So if a pod's init container fails, Kubernetes repeatedly restarts the pod until the init container succeeds. However, if the pod has a restart policy of never, Kubernetes does not restart the pod. So you can even consider this as one of the example of your multi-container pods. Okay, so earlier we have seen in our initial Kubernetes fundamentals, we discussed about running only one container per Kubernetes pod. But if you want to run multi-container pods, so these are some of the examples like init containers or envoy proxy or few of the things. Okay, so now let's go ahead and then implement the init containers. So let's see what is this actually. Okay, so under the pod template spec, so which is nothing but init containers will be one of the equivalent level to containers whatever we see in our pods. So let's go here and go to user management microservices deployment. So you see here containers, right? In the same level you can have the init containers. Okay, so init containers. So that's the thing I'm discussing here. Okay, and so you can have the name of your init container, and we are using a simple busybox image here. And then what we are going to do is, so we are going to check from our init container in user management pod that whether my MySQL service is up or not. So every time in a while loop, we are going to say netcat-z MySQL, which is nothing but the MySQL cluster IP service, and then 3306 port. So I'll keep checking regularly until and unless it is up. So once it is up, I can say MySQL DB server has started, and then this task will be completed. The init container task, whatever we have provided, it will be completed, and then it will move on to the containers present in the container section, which is nothing but our user management REST app. Okay, so let's copy this stuff here from whatever we have, everything. So let me copy these things, right? So and paste it. Okay, so under init containers, so we have the name initdb, and the image is busybox image we are using, and the command we are going to use is a shell script with the netcat-c under shell netcat-z and then MySQL 3306. So let me save this, and we have used the all other templates as is from our previous 0501 section, and we updated only user management microservice deployment section with the init container. So now let's go ahead and then test it now. So you should be in 0502. So let me go for 05 section important concepts, and I should be in 0502 Kubernetes init containers. Okay, so now let's see, the next step is to create the Kubernetes manifest, means like create all the Kubernetes objects. Okay, so kubectl apply -f kube manifest. Okay, so now it need to create the pods. So let's see what happens. So now we can watch the pods, kubectl get pods, and you can see that init container is running now. Okay, so we can even put in the watch mode. -w means kubectl get pods, -watch mode means whatever is happening. So now MySQL got running, so that now init container should pick it, and then it should be successful, and then start the user management container next to that. Okay, so now see, init container is successful, and then it is initializing the user management container inside that. So pod is initializing inside that, and we'll wait for it to be in running status. So it's running now. Okay, so now let's see one more time, kubectl get pods, and our user management microservice should be running. So now one thing we need to do here is, so in the kubectl get pods output, you can see that there is no restart happened for our microservice. Okay, because it waited for the MySQL container to come up, and then only it started the user management REST app container inside this user management microservice pod. Okay, so now one thing important here we need to see is describe the pod. Okay, so I'll say kubectl describe pod and this complete pod information. Okay, so copy and then paste. So why we are going to see is, like, we can see two types of containers present here. So let's come up. Okay, so successfully assigned the pod scheduling, and then to the default namespace, and then it has the container image, and then it created the initdb container, and then once it started and then it completed, then it started running the next container, which is user management microservice. Okay, so created that container and then started that container. So now the one thing we need to see here is what all containers, right? So if these are the events, whatever we have seen, what happened. In addition to that, we can also see init container here, right? So which is the initdb container. So it executed the command whatever we have provided inside that, and verified that MySQL DB server has started or not. So reason is completed. You can see, right? It completed. So as soon as it completes, then it immediately terminates that container. Exit code is going to be 0. And then it will move on to create the user management REST app container next to that. Okay, so it created this container and then started this respective container. So this completes the init container concept applied to our user management microservice. If we want, even we can access our health status page and see that it is up and running. It's up and running now. Okay, so now let's go back, and we have created and then tested. Let's go ahead and then delete the stuff. Okay, so copy, and then I'll say clear, and I can say kubectl delete -f and then kube manifest. So everything whatever we have created, we are going to delete. Okay. So in our next lecture, we are going to see liveness and then readiness probes. Okay. So if you want more information about pod init containers, you can click on this and then read about those things. This is the direct Kubernetes documentation link, which will provide you more information about init containers. So I'll see you in the next lecture. Until then, bye-bye. Thank you. Welcome back. In this lecture, we are going to understand about the probes available in the Kubernetes. So we have three types of probes available. So one is liveness probe, readiness probe, and then startup probe. So liveness probe. So kubelet uses liveness probe to know when to restart a application container. So in general, if our application has some deadlock appeared inside that and then it is not able to progress more, and then if liveness probe is detected as failed, then automatically the container will get restarted. So whenever we have application failure situations and then if liveness probe fails, it will restart the container so that again fresh instance of the container will start up and then start taking the traffic. So liveness probe will be used for that reason. So now the name here readiness probe states that kubelet uses readiness probes to know when a container is ready to accept the traffic. So until and unless the readiness probe is succeeded, so we will not allow that container to get the traffic. In simple terms, whenever we start or deploy our application, so we will wait for the settings provided in readiness probe to succeed, and once it succeeded, then only it will allow the traffic to that respective container. So when a pod is not ready, it is removed from the service load balancer based on the readiness probe signal. So if the pod is not ready, then ideally it cannot be go and then add to the service load balancers, right? So in that cases, readiness probes will be very much helpful. In other terms, like you have a elastic load balancer with application load balancer or any other load balancer, classic load balancer or whatever the load balancer may be. So this respective pod, if it need to go and then register inside the pod, then readiness probe should be successful. In understanding and then handling those type of signals, readiness probes will be helpful as an example. And next is the startup probe. So kubelet uses startup probes to know when a container application has started. So ideally, when a container application has started, why the startup probe should know, means like why the kubelet should know when the container application has started. So there will be several reasons for that. Okay. So firstly, whenever we configure the startup probe, it automatically disables the liveness and then readiness probe until the startup probe is successful. That is one thing, to avoid any interference with the app startup. And second thing is, this can be used to adopt liveness checks on slow starting containers, avoiding them getting killed by the kubelet before they are up and running. So if sufficient amount of time it already took to start the container, usually the default timeouts of pods and then Kubernetes will kick in, and then it will go into an infinite loop of terminating and then restarting. So to avoid such situations for the slow starting containers, application containers, so we can use the startup probe. And important thing here is, whenever the startup probe is in action, until and unless it succeeds, it is going to disable the liveness and readiness probes, even they are defined in our manifest, deployment manifest. And next thing here is options to define probes. So there are three options to define the probes, means like in three ways we can define the probes. Either it is a liveness probe or readiness probe or startup probe. So one is check using commands. So we'll have shell scripts, right? So we can create using shell that netcat-z localhost 8095 to check whether that respective localhost with that port is available or not, or any other cat command or whatever the command, whatever we want to use to ensure that our application is up. So we can use those shell commands. That is one way. And the second way is using the HTTP GET request. So example, like you have a health status page in your application, and when your application is up, then you can provide that health status page link so that using HTTP GET, it will go ahead and then check that respective page is available for us or not. Or using plain TCP socket connection, which is nothing but whether the port 8095 is listening and then up and running or not. So in these three options, we can define our probes, whatever is applicable to whatever the probe in our respective application situation. Okay, so example readiness probe, I want to define using HTTP GET, I will define with that. Or my liveness probe, I want to identify like in such a way that using nc-z and then localhost 8095. So I'll assign for this. Anything, anywhere you can use, but the way how you want to define it depends on your application context and then how you have defined your core application. Okay, so no restrictions on using which to which. Okay, so all three can be used for all three types of probes. So in our next lecture, we will focus on creating the liveness and then readiness probes for our user management microservice and then test it now. Okay, I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So we have just now completed step 01 introduction for liveness and then readiness probes. So now let's see what are these and then how we are going to define them in our user management deployment manifest. Okay, so we are going to create both liveness and then readiness probes, and the liveness probe we are going to define using command, which is nothing but liveness probe with a command sh-c and then netcat-z localhost 8095. And for readiness probe, we are going to do it with HTTP GET and then path with our same user management health status URL, whatever we used to test earlier, right? So the same thing with port as 8095. And we are going to also provide initial delay seconds and then period seconds. So we'll see what are those things. Usually initial delay seconds are nothing but number of seconds after the container has started and before liveness or readiness probes are initiated. So the amount of time after container started and then readiness or liveness probes to be triggered. So the difference time, how much it need to wait before triggering these probes. So the reason for that is once we start the container, so just for the application to settle down, start and then settle down, we can give some amount of delay, right? So usually 10 seconds or 30 seconds or 50 seconds or 60 seconds. Okay, so default is usually 0 seconds, means like default is 0 seconds and then minimum value allowed here is also 0 seconds. But the core thing here is we really don't want that edge to be given and then it got failed, liveness probe or readiness probe to be failed. So usually we'll give 10 seconds to 30 seconds based on our application. But for our demo, I have given 60 seconds so that until and unless these 60 seconds are completed, you are not going to see that pod is running. It will not come into the ready state. Okay, so always it will be showing 0 by 1, not 1 by 1 in the ready state. We are going to identify that now. But so to differentiate that or to show that, I have put 60 seconds here, but in general based on your application you can put 10, 20 or 30 seconds. Okay, so let's go ahead and then define liveness probe and then readiness probe in our application. Okay, so here is the thing. So now if you see here, so it is a image level, means like container level definition, this liveness and then readiness probes. Okay, so here name you see, right? Name, image, ports and then environment. At the same level we need to write our liveness probe. Okay, so I can say liveness probe. Okay, so I can minimize this and then now go up and then start writing for the liveness probe. Okay, so it can be now then for the liveness probe it is going to be exec, right? Execute the command. Okay, so execute and we are going to have a command. Always I am typing tab and we are going to have 3 commands. Okay, so one is bin sh and which is going to be -c, right? -c, and next is nc-z and localhost 8095, right? And another thing which we need to implement under liveness probe is, okay, so there will be exec, it will execute this command and also it will add the initial delay seconds. Okay, so which is going to be 60 seconds. Okay, and there will be one more called period seconds. Okay, so which is nothing but how often in seconds to perform the probe. Default to 10 seconds. So every 10 seconds we will do the liveness probe check and then also the readiness probe check. Okay, so we can say period seconds and then 10. In addition to these two things, we will also have some other timeouts here. Okay, so there will be a documentation link here exactly to the Kubernetes side. So if you see here at the end, you will find other stuff too, which is nothing but timeout seconds, number of seconds after which the probe times out. Default is 1 second. Minimum value is also 1 you need to provide. So successful thresholds, minimum consecutive success for the probe to be considered successful after having failed, or failure threshold. So like this, if you want to still exclusively define other stuff like timeout and then success thresholds, failure thresholds, you can go ahead and then view this documentation link and then add those. So for now, we are giving initial delay seconds and then period seconds. So in the same way, we are also going to define the one more thing, which is readiness probe. Okay, so I am going to copy paste it. One we already have live written it, right? So another one we will try to copy paste it. So it is the same one. One is liveness probe and next is readiness probe. And here, instead of execute command, we are going to use HTTP get. In HTTP get, the core thing is to which path it need to find it and port which one, 8095. So we have the user management health status page available in our application. So we provided that and port. And if you want, you can define your host here, but default host is going to the pod IP only. So we really don't need to define that. As usual, we'll have initial delay seconds and then period seconds. Okay, so anyway, liveness probe we have defined here, but we can't test that. The reason is like our application, we are not crashing or we are not taking into any deadlock situation. Okay, so we cannot replicate that in this respective demo. But for readiness probe, yes, we are going to see that whether after the container got started, it is going to take it is going to wait 60 seconds to make the ready state of the container part to be one by one. We are going to see this and then understand that. Okay, so let me save this. So I have saved it. So now we are good. So let's go back to our terminal and we should be in 0503 Kubernetes liveness and then readiness probes section. Okay, and we are going to say kubectl apply -f and then kube manifest, and then it should start creating all the stuff for us, all the objects whatever related to it, storage classes, persistent volumes, config maps, all the deployments. So we are going to say get pods -w. We are going to watch it. Okay, so first thing is it is going to create the MySQL container. Till the MySQL container is created, microservice pod is going to wait because init container will be there, right? So until and unless this is running, it will be in the init container state. And once the init container is successful, then only user management microservices application container will start, right? So init container is successful and then application container pod initialized and then it started, and then you are seeing 0 by 1 and it is 28 seconds now and it is 0 by 1. Ideally by this time it should, if there is no readiness probe, automatically it will be 1 by 1 here. Okay, but we have the readiness probe for 60 seconds for the initial delay after the container got started, which is nothing but the application container, user management REST app container. So it is going to wait for 60 seconds. Okay, so let's see, now this is 28 seconds and after 60 seconds it is going to come as 1 by 1, or after 60 to 68 seconds. Why? Because after that again it need to run the readiness probe in 10 seconds interval, right? So hardly within 70 seconds, which means 70 plus 28, 88 or 98 seconds. By that time usually our application should be up. So let's wait for that and then see what happens. So now you can see after 95 seconds our application is up. Okay, so now if I go here and then verify this, so our application should be up and running. So our readiness probe started working here. Okay, so now I can say Control C to go ahead and then clean up the stuff. In our next lecture we are going to focus on requests and then limits. So those also very important concepts required for our applications to define. So we are going to look into that requests and limits, and then we'll move on to other concepts of namespaces. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to implement requests and then limits, which is nothing but resources for our container inside the pod, right? So if you see here, on a very high level, we can specify how much each container in a pod needs the resources like CPU and then memory. When we provide this information in our pod, the scheduler uses this information to decide which node to place this pod on. In simple terms, so once we provide this information, so scheduler will find out on which node I have the equivalent resources, whatever provided is available, and based on that it will go ahead and then schedule it. So when you specify a resource limit for a container, the kubelet enforces those limits so that the running container is not allowed to use more than the resource, the limit we have set. In addition to that, the kubelet also reserves at least the requested amount of that system resource specifically for that container use. So these two are very important. So if we have some critical container we are going to run on Kubernetes, which should always have that set of CPU and then memory. So using these resources like requests and then limit for your respective container, which is so critical application, so you can reserve the memory and CPU what it needs. In addition to that, in high traffic conditions, it might increase to 500 MI of memory and then 1000 M of CPU. So then automatically you can even provide the limits, but it should not cross more than this. So like that you can even provide these things. So 1000 M is equal to 1 vCPU core. Okay, so we have provided 0.5 CPU, which is nothing but 500 M. In the same way, memory also 128 MI we have given, which is nothing but maybe bytes. Okay, so 128 maybe byte is equal to 135 megabytes. Usually we will say 1024 MB or 100 MB or 5 MB, right? So in the same way you can define here maybe bytes. Okay, so I have provided 128 maybe bytes of memory for my application, and CPU I have provided 500 M, which is nothing but the means milli CPU. And I also provided the limit that for my user management microservice application, I should not give more than 500 MI of memory and 1 core CPU, 1 vCPU. So now if you see, we are using 2 T3 missions here, right? So if we go ahead and then provide the limit as 5 CPU, means like 5000 M, right? So based on our limit only, it will go ahead and then schedule, right? So our 8000 CPU. So and if my respective 2 T3 missions doesn't have that, then automatically the pod will go under pending state. Okay, so it will not come and then create it. So that's the reason always whenever we are evaluating our resources, requests with the memory, CPU, limits and then requests, so we need to ensure that what is my cluster size and then all those things. But the other hand here is whenever we go to the auto scaling concepts, right? So horizontal pod or vertical pod or cluster autoscalers, whenever you enable those things, so these things really doesn't matter, which means once you define these things for your specific things which are critical, and already you enable the auto scaling stuff there, so whenever things reaches the limits, automatically the cluster will auto scale with nodes, and in addition to that it will also scale whatever the resources it is required. So based on that, usually it will not have an issue. But if you are using small clusters and then if you have trouble, right, in defining those things, so then obviously you need to be very careful about what you are defining and then how much your application is going to consume. So with that said, we can go ahead and then define these things in our application, right? So which is nothing but resources, requests, memory CPU, and then limits, memory CPU. Okay, so this is part of our container definition, so which is nothing but which should be under environment same level, which is LivenessProbes, ReadinessProbes, and it should be here also at the same level. Okay, so which is nothing but resources, and under that we'll have two things, one is requests and the other is limits. Okay, under requests we are going to have CPU and memory, right? And under limits also we are going to have CPU and memory, and you can copy and paste whatever is there available here, right? So memory is going to be 128 MI, right? And CPU is 500 M. Okay, so in the same way here also the CPU is going to be 1000 M, right? And this one is going to be 500 MI. Okay, so for this demo I am going to put this, and then later I am going to remove this resource request in the next lectures. Means like in all the templates I am going to remove these things. Why? Because I really don't want to block my cluster related resources for 500, means like half CPU and then 128 MI for this respective user management microservice only. So if it want to take how much it want to take, it can take it. But if I want to scale this, right, means like if I scale to 10 and then automatically my cluster, whatever is 2 T3 medium servers, might go into pending state. So that's the reason I'm going to remove, and the next templates, whatever you see in the next sections of here, whatever you see, these might not be there, but you really don't need to worry. We learned it in this section, and then after that we removed it. Okay, so let's have it that way. Okay, so let me save it. Right, so we have saved this one, and now what we are going to do here is we'll go back to our create k8 objects and then test it. So let's go back to our terminal. So I am in 0, we'll go to 05 section, and then 0504 section we need to go, which is requests and then limits, and I'll clear and kubectl apply -f and then kube manifest. Okay, so and then everything should get created, and then ideally we should not have any issue. So why? Because our cluster has that level of capacity. So and then we can watch the pods here, and it will take a while to get the container, MySQL container gets created, and then from init container it need to go to Liveness and then ReadinessProbes. All those things will take, right? So until it is ready, I'll pause the video. So our pod is running now, user management pod. So let me come back out of this, and then I can say kubectl pods, and then all are running. So we can go to browser and then verify, and our application is up and running. So one thing we can check here is kubectl and then get nodes, and then let's see our node, right? So kubectl and then describe one of the node, right, to understand what we have, how the resources are distributed for that node, right? So I just need to provide the describe node here. So let me do that, right? Okay, so if you see here, so for MySQL we didn't define any CPU requests or CPU limits. Okay, for kube system AWS node already it is defined, which is system related stuff. Okay, or for kube system kube proxy also 100 M of CPU is reserved for them. Okay, in the same way, let's see in our default namespace we have something called user management microservice. Okay, so let me make this smaller and then see what happens. Okay, so I just reduced the font to understand little bit clear. So you can see in the default namespace we have user management microservice. So we have requested 500 M, means like my request is 500 M and my limit is 1. So what is this 25% and then what is this 51% is? From this node, of 25% of this node I have already requested, and then I'm going to, that is reserved for this respective user management microservice. Okay, and its limit is I'm going to use 1 CPU, which is nothing but, if you see here for the T3 medium, so if you come here, right, no, not this one. Okay, yeah, so if you come here for the T3 medium, so you have something called 2 vCPU and then 4 GB of memory. So out of 2 vCPU, 1 vCPU you have already reserved for this user management microservice. What it states for us is already you are using 51% of the CPU from this respective node. So that's what it is trying to tell us. In the same way, 128 MI I am using as a request, which is nothing but 3% is already reserved from the entire 4 GB. And in addition to that, 500 MI, which is 14% is reserved for this limit. Okay, so how much is the limit here? It is 4 GB, out of which this much it is reserved, it is saying. In the same way, if you see here, this is the overall for this node. In the same way for the other node also we'll have, right? So in that line, so whenever we are defining the requests and then limits for our respective containers, we need to ensure that proper planning is required, and then if my cluster will sustain in high load conditions or not, and considering the cluster level resources what it consumes, like whatever the kube system or whatever is present in the kube system, like in future you might install external DNS or ALB ingress controller, lot of other things will come into the picture which are system related. So for all those things considering, we need to ensure that how much this cluster can allocate, and then accordingly we need to decide. So this completes the understanding of resources and requests, and then we have also implemented it. So let's go ahead and then delete them now. So let me paste it and then delete it, and let's also go back for our previous font. Okay, so in our next lecture we'll focus on namespaces. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in this lecture we are going to understand about Kubernetes namespaces on a very high level. So namespaces are also called virtual clusters in our physical Kubernetes cluster. Why? Because we create a Kubernetes objects inside these namespaces which will be isolated from other objects outside of this namespace. So that's the reason we call it as a virtual cluster. So usually these namespaces are used in environments where we have many users spread across multiple teams or projects. So we have many projects and then many teams which are accessing all these projects deployed on the Kubernetes cluster. And if we want the complete isolation boundaries defined for these each teams or the environments, then we can use the namespaces. For simple clusters with the minimum number of users or minimum number of applications which we really don't feel as complex, we can directly don't need to use namespaces. But personally, what I recommend is, this is what Kubernetes recommends, but personally what I recommend based on my experience is start using namespaces. Irrespective of if you use the resource quota and then other advanced options, at least if you start using the namespaces and then pushing your objects to that respective isolated boundary, excluding the resource quota concepts. So what happens here is like you will get a lot of advantages when you are getting to experience those things. You will understand better. But my personal recommendation is start using namespaces. Even in these tens of users of in this area also start using namespaces. It's no harm in having your objects dedicated in a namespace instead of having them in a default namespace. Irrespective of if you don't use this namespace concept also, whatever you are creating is going to go into a default namespace. So if that is the case, what is wrong in using namespaces? So that's my recommendation. So moving on, so what are the benefits we are going to get? So when we create these namespaces, it creates the isolation boundary from other K8 objects for the objects whatever we have created inside that namespace. So we are going to see all those things in our next slide. We can also limit the resources like CPU and memory on per namespace basis using the resource quota option available in Kubernetes. So you can create a namespace and provide the resource quota like it need to use only two CPU cores and then 4 GB of memory. So you can do that. So that's the reason you can even call it as a virtual cluster. So now moving on. So how to get the namespaces? So you can say kubectl get namespace, and then you will get the by default whatever has created as part of the cluster creation. So Kubernetes cluster creation, all those default namespaces will be available. So let's start with what is this default namespace. So let's understand this default namespace is nothing but so far whatever we have done in our continuous previous lectures, whatever we have done so far, whatever we deployed, all objects were deployed under this default namespace. Our user management application or our Nginx application, whatever we have done, all those are getting under this default namespace. That's the reason whatever I say is like whatever we create anyway going into one default namespace. Instead of that, if you want to clearly and then claritily manage your objects in Kubernetes, start trying to use namespaces. And next thing is kube node release. Okay, so this namespace is for the release objects associated with each node, which improves performance of our node heartbeats as the cluster keeps scaling. Okay, so using the auto scaling when the cluster is scaling, so this using this kube node release, we are going to have the better performance of our cluster. Okay, but the core thing is we really don't need to worry about that, or we really need to look into that one. So one more will be there, which is kube public. So this namespace is created automatically and is readable by all users, even the unauthenticated users of my Kubernetes cluster. So this namespace is mostly reserved for cluster usage in case that some resources should be visible and readable publicly throughout the whole cluster. So kube node release and kube public, we really don't need to worry about these things. Okay, so one thing which is default, where we create by default whenever no namespace is mentioned, it is going to go into default. And the another thing which we have is kube system. So this is what we should be aware of. So all the Kubernetes system related objects will be created in the kube system. So let's go ahead and then see that now. So let's see what all present in our kube system namespace. Okay, so I'll say kubectl. Okay, so get all objects and then hyphen namespace kube hyphen system, right? So it will provide all the objects present in our system. Okay, so you can see it here. So the following pods are present, and then you also have a service named kubedns, which is a cluster IP, and you also have AWS node 2 pods, and then core DNS 2 pods, and then EBS CSI controller, which is Elastic Block Store CSI controller 2 pods, and CSI node, which is a daemon set running on each of our cluster nodes. 2 cluster EC2 instances we have, and on them they are running. And we also have kube proxy. So you can see AWS node is a daemon set, and EBS CSI node is a daemon set, and kube proxy is a daemon set here. Okay, and in addition to that you have core DNS and then EBS CSI controller deployment created, and you also equivalent replica cells also you can see here. So kube system is nothing but all the system objects are running here inside the kube system namespace. So let's understand little bit. Okay, so kubectl get namespaces, you can say ns is the alias for namespaces here. Okay, and in addition to that, one thing we have done just now is kubectl get all, right? So and then hyphen namespace we have given. You can even give -n and then kube system, and the output should be same, right? So get all objects from the kube system using -n. So that's about it. Okay, so now let's come back and we'll move on to the next slide. So here what we are going to understand is a pictorial representation of our namespaces. So if you see, I have a simple application with a simple backend application. So maybe my REST service application, which we have seen in our previous examples, and then which is fronted with a Nginx proxy, right? So now whatever my backend application, whatever I do the deployment, when it creates a replica set and its equivalent pod. At the same time, to access that inside the cluster, we create a cluster IP service. And once for the front end service, you create the deployment and automatically replica set and then pod created. And if you want to access via internet, you can use node port service or the load balancer service. Okay, so now all these objects are packed under a namespace named dev. So which means whenever you create these objects, you can direct them to create it directly on the namespace dev. In the same way, if I want to create QA, again the same objects can be created in QA. So now if you see, by default, if this gets created in default namespace with the same names, they cannot get created in the same default namespace one more time. But now our namespaces are different. If example, this deployment name is backend 1. Okay, so now it is in dev, it gets created, and in QA it gets created. In other environments it gets created. How it can get created is because of it is completely a isolation boundary for all these objects using these namespaces. Now let's see the namespace manifest in a declarative manner. So as usual, our standard template is API version, kind, metadata, name, and then spec. So namespace doesn't have any other additional information. We really don't need to have any spec there. So you will have API version is v1, kind is namespace, and metadata inside that name. I'm giving my namespace name as dev3 here. Okay, and if you want to do it in imperative way, again it is going to be very, very simple, which is kubectl create namespace dev1. That's all. So this is a very high level introduction about the namespaces. So in our next lecture, we'll go ahead and then create applications in dev1, dev2 namespaces and then understand it better, and then get our hands-on with these namespaces. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So let's go into our GitHub repo 0505 Kubernetes namespaces. So we are going to deal namespaces in 3 ways. One is we are going to do it in an imperative way and then just understand in a quicker way what is namespaces, and then how we are going to create multiple environments with the same Kubernetes manifest using imperative way. And then we are going to write a manifest for namespace and also for limit range, and then implement the limit range concept for namespaces. After that, we are also going to implement the resource quota concept. So we are going to write that respective Kubernetes manifest and then implement that. So let's do that step by step now. So we are going into 0501 namespaces imperative. So introduction part we already took care in our previous lecture. So let's start with namespaces generic deploy in dev1 and then dev2 environments. So what does this mean, dev1 and then dev2 environments? So we are going to create two namespaces. One is nothing but dev1 and the other is dev2. And we are going to deploy the same manifest. So whatever we have created as part of request limits till that time. So all those manifests, okay. So 8 manifests which will create a background of MySQL database and then front end as a user management microservice, and then which will call the MySQL database as its persistent store. So and then all that whatever we have built so far is available here, and the same things whatever from previous section I have copied here to kube manifest, and then we are going to leverage that. So let's first go to our terminal and then verify and what are the existing namespaces, right? So we have default and then whatever is provided, the current 4 namespaces. So we are going to say kubectl create namespace. So you can say even namespace or even you can say ns. So I'll start using aliases so that it will be easy for you later. So instead of typing entire namespace, right? So and also I'll create one more which is dev2, and then I'll say kubectl get ns, which is nothing but namespaces. So now you can see dev1 and then dev2 also created 8 seconds and then 6 seconds back. So let me clear. And now one important thing we need to do in our user management node port service is we have provided the node port as 31231. So as you know, what is node port is nothing but the worker node port. It is going to tie with that. So 31231 will be our worker node EC2 instance port. So if we keep deploying these templates in multiple namespaces, so every time it cannot attach it to the 31231 node port, and then it will have the error, because for our EC2 instances 31231 is only one port, and then it cannot be shared across multiple namespaces. So if we comment this part in our respective user management node port service, so then automatically Kubernetes is going to assign the dynamic port for node port. So let's go ahead and then comment that now. So why we are doing this one, okay, I can take a simple Nginx application and then show you how to do all these things in namespaces. But the thing here is, whenever you go into a bigger things, then only the problem starts, or all these types of issues you will understand and then you will be able to resolve. So that's the reason we have taken one set of application with MySQL and then front end as REST service, and then we started with EBS and then we have come till here. Okay, so I'll go to user management service 07, and you can see this is already commented. If not, you can go ahead and then comment it. So now the node port assigned for this service is going to be dynamic. Okay, so I commented it out. So let's come here, and now we have commented it. So we'll go ahead and then deploy. So as usual, we are going to deploy with our standard command kubectl apply. Okay, so kubectl apply -f kube manifest. So whenever I do this, it is going to deploy to a default namespace. So you need to tell the system in which namespace it is going to deploy. So I'll say -n and then deploy it in dev1. So means like this command will deploy all these objects in dev1 namespace. In the same way, once this is done, we'll also do the deployment in dev2 namespace. Okay, and now you see that creating a MySQL database and then its front-end application deployment, everything in multiple environments is like seconds we are doing it. So that's the advantage of Kubernetes. So how fast we can do, and then everything is speed here. Okay, so now let's go here, and then we have deployed it. So we can even say kubectl get all -dev1. So what all deployed in dev1 we are going to get here. So we have 2 deployments we have done, and then 2 services got created, and then 2 pods got created, which is MySQL and then user management microservice pod. In the same way for dev2 also you can verify, and then all those will be in dev2, right? And you can even say kubectl get all, and from default namespace you should get nothing, right, other than the cluster IP service of Kubernetes. Okay, you can see, right? So now you can clearly confirm that these things were deployed in those respective environments, means like those respective namespaces. So now you can verify few stuff here, okay, right? So you have got pod, service, deployment, and then replica set. So what happened to storage class and then PVC and then PV, right? So now you need to understand one thing here. Those are not generic objects here, okay? So which means you can say kubectl get PVC. So it will provide the persistent volume claim. In default namespace, nothing. But if you see in dev1, it should be there, right? In dev2, it should be there. So persistent volume claim is a namespace level of object. It is present in those namespaces. And then if we specifically query for it to verify, you can see those things here, okay? So now let's also verify kubectl get pv and then hyphen dev1 and then hyphen dev2. So okay, so nothing. So these are not specific to namespaces. Even if you give get pv, you are going to get, means like the persistent volume created and then associated with those namespaces, right? From dev1 it is associated here, and for dev2 it is associated here, right? So whatever it is associated with the claim, PVC claim, right? So it is not specific to respective namespace, means like the storage volume, whatever is mounted here is not specific to that namespace. In the same way, you can also see get sc, which is nothing but the storage class. Even that is not specific to respective namespace. So these are generic objects and then created generically, not pointing to any specific namespaces. So now one thing we need to do is we need to go ahead and then access our application. So to do so, we need to get the service port, right? So the port is 31115. That is the port. And for this one also we'll get the port, and then I'll also get nodes -o wide. Okay, kubectl get nodes -o wide. I got the public IP. I'll copy it and then access one after the other. I'll go here and then say provide this, and then 31115, right? 31115. This is the one for the first dev1 environment. And I'll say user mgmt health status. And you can see that this is up and running, right? The first dev1. Now we'll go and then check for the second one. Second one's port is 30011. Okay, so 30011 / user mgmt / health status. Okay, and here also it is up and running. So it took few seconds or few minutes to create the environments with the same set of stuff. The power of Kubernetes YAML declarative style, and also the power of namespaces we have seen now. So that's all about the namespaces in an imperative way, creating them, and using kubectl apply how we can redirect all our templates to be created or all our objects to be created in that namespace. So this completes our current 050501 section. So in our next section we can focus on other topic here from namespaces perspective, which is limit range. And if we want to clean up all these things, so there are two ways to clean up. So this is a cleanup step. So one is whatever you have created, apply whatever you have done. You can say delete -f and then kube manifest and then -n dev1. With one command everything is done, right? So but there is also other way to do it, which is nothing but with one command only, which is nothing but kubectl delete ns, which is nothing but namespace, and then dev1. So entire dev1 objects will be created or deleted. Okay, so means like when that namespace is deleted, all the objects present in that respective namespace also will get deleted. And let's, after this deletion, we'll also delete dev2, but only one thing will be remaining at the end, which is nothing but storage class, which is generic. So that you need to separately go ahead and then delete that respective storage class. Okay, So in this concept, we have storage class, but you might have different applications you are deploying. So in that case, with one command of deleting that namespace, everything will go away. Okay, so I'll also delete dev2, and after that I'll also delete the storage class, and then after that nothing will be available for us. Even the namespace is not there. You will not be able to see what is present in those namespaces, right? So once dev2 is deleted, we'll delete the storage class also. Let's also delete the storage class. kubectl delete sc ebs-sc is my storage class name. I have deleted it. And kubectl get all. We are going to get all objects from all namespaces. Okay, so -- all namespaces. Okay, and we should not see anything related to our user management or MySQL or anything. Okay, so you can see we are getting only the pods which are related to our system, kube system. So you can see all the namespaces you can see in this list: kube system, default kube system, and then kube system. But we really didn't see anything about our dev1 and then dev2. You can even say kubectl get ns, and then you will find nothing about dev1 and dev2 because those namespaces we have deleted it. So let's catch up in our next lecture with the limit range. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about limit range concept in Kubernetes in relation with the namespaces. So we are going to deploy our applications in the namespaces, and at that point of time, what is the use of this limit range concept we are going to see practically. So let's go back to our requests and limits section, whatever we have implemented earlier. So in 0504, we have implemented requests and limits section, wherein if you go to our user management microservice container, right? So in this deployment, so we have added the resources section here, right? And under resources, you have said that these are the requests and then limits, and then my container can request for this CPU and then this much memory as an initial state, and then it can go up to this much limit, and then not above this limit it can use. So my respective container, whatever is going to be as part of this deployment, so this user management REST app container can have the requests as this much and then limits as this much. So every time if you want to add these things, you need to add these things in your, means like if you want to define your limits and then requests related to your resources in your container, means like for your respective application, then you need to update their respective deployment of that application, if it is MySQL or if it is whatever, right? So in requests and limits, we didn't implement anything for this. So this doesn't have any limits here, or this doesn't have any requests. But user management microservice, you have it. So every time you need to take this snippet and then update in your MySQL deployment here, and then change whatever is or tuned parameters, whatever you want to use for MySQL, you need to define. But there are other options available as part of limit range, which is nothing but the automatically applied to these things. So let's see what is that. A default option is available here. Let's see that. Okay. So you have a namespace dev, and then you have both the backend and then front end application. So front end, let's consider as whatever it is, Nginx, and then backend might be some other REST services application. Okay. So whatever it may be, so you will have a limit range. And then with limit range, you will be able to control your CPU and then memory. So in two ways. So one is default and the other is min and then max. So you can assign a default CPU and then default memory for the container present in this deployment and container present in this deployment for all the containers present in this dev namespace. So which means whenever you apply the default option of limit range, so you can have the default CPU and memory associated for those respective containers present in this namespace. So whenever you say default and then some CPU and some memory you associate, all the containers present in this namespace are going to get that much things. Okay, so you really don't need to go ahead and then define this resources section in your respective deployment. So we are going to see that now by applying this practically. Same way it is for QA and then staging environment. So once you define your limit range here with CPU and memory as default, so then automatically those default CPU and memory values are going to get applied for the containers present inside this namespace. I am repeating again and again to get the super clarity on what we are doing. So here it is. Okay, so limit range manifest. As usual, API version, kind, metadata are going to be same. But you can see here we are going to associate this limit range manifest, means like we are going to create this limit range manifest in the namespace dev3. And under spec you will have limits, and under limits you will have default and then default request. So default is nothing but the default higher limit, how much it need to have, means like this respective backend container or front end container need to have. And then default request is nothing but, in our concept we have the how much it is going to request initially. Okay, so this one. Okay, so this default refers to limits, and the second default request refers to requests. Okay, so now memory and then CPU, my limit I have given for each container in this respective namespace, in this respective dev3 namespace. For each container, maximum limit of each container is 512 MB, and then CPU is 500 M, which is nothing but 0.5 of one core CPU. And default request, which is nothing but how much initially it can request, is 256 MB, and CPU is around 300 M. And to whom all these things need to be associated? Per container. Type is equal to container. You can see it here. So that's about the limit and range on a pictographic way, or explaining it in a concept model. So now we'll go ahead and then manually implement it, write this manifest and then test it and then understand it better. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. Let's get into our limit range default concept here. Okay, so 050502 namespaces limit range default. So as a step 1 we are going to create a namespace manifest, and then as a step 2 we are going to create the limit range manifest. Okay, and then we are going to update all the manifests with respect to namespaces with namespace dev3. So let's understand this little bit later. Okay, so let's complete the creating the manifests for now. So let's go back to our Visual Studio Code, and if you see here we are in 050502 namespaces limit range default. So if you see 01 to 08 are same from whatever we have took from imperative command, or whatever what it is coming or getting forwarded from previous sections. Okay, so which is 01 to 08. In 00 we have going to create a namespace and then limit range default related manifest. Two manifests we are going to create here under 00. So now the question comes, why we are going to put it as 00. So the reason we are putting the 00 instead of 09, why you are putting it as 00 as the first one? Okay, because you have two options to create a namespace. One is imperative, or other way is declarative. And in declarative also you can create first namespace and then later you want to create all these things, right? Because all these things need to be created inside that namespace. So if that is the case, if you put this as 09, so then it is not going to, all these are going to be in error. So if it is in order from 00 to 08, first it will create the namespace and then rest all it will get created. So that's the reason I have given 00, because I want to create all these things with a single command, kubectl apply -f. Okay, so I really don't want to first create kubectl apply -f and then first this file, and after that rest of the files. I really don't want to do that way. So with one command I want to create it. So that's the reason I have put it under 00. So we have discussed more about this ordering. So now let's go ahead and then create the namespace template. Okay, so as usual we will start with API version, and then we'll have something called kind, and we'll have something called metadata, right? And we'll have something called spec in our standard stuff, right? So now let's also copy this, and we are also create one. We are going to create one more, right? One more manifest here. So if you want to separate the YAML to YAML definitions, so you can give this way. Okay, 3 hyphens. Okay, right? So now I'll put it this way. So now the one is namespace one we are going to create. So I'll say kind is going to be namespace, and API version is v1, and metadata, and under that the child element we can have name, and then name is dev3 namespace. Okay, and namespaces doesn't have any spec concept, so I am going to remove the spec here. Okay, so now the next one starts, which is the limit range. So let's go ahead and then quickly create the limit range. Okay, so the kind is limit range and the version is going to be v1, and we'll have two things here. One is name of my limit range, and the second is namespace it is going to belong to. So why I am writing namespace? Because with one command I want to create everything, and then I want to hard code the namespace in each of my Kubernetes object. Okay, so we are also going to update this namespace dev3 in all the things also. Okay, so in all these things also we are going to update later, but for now let's leave it like this. And then I'll say name, and name I'm going to put it as default CPU mem limit range. Okay, and namespace it is going to be dev3. It is going to create in dev3 namespace. And under spec you are going to have only one thing for limit range, which is nothing but limits, and you will have the default limits you can define here, so which is nothing but the limit, maximum limit how much you can define for memory CPU. And one more you will have default request. Okay, and one more at this level you will have something called type. So to whom you are going to define these limits. So of type container these will be applicable. Okay, so that's all. So now let's go ahead and then define our CPU and memory, right? So I'll say CPU and then I'll say memory, and in the same way here also CPU and then memory. So this is the template for limit range. So now you can define whatever we want. So I'm saying per container, mine is a small T3 medium cluster, so I am giving 512. I'm going to run only 2 pods, so it might reach 1 core when I say 512 MI, right? So like that. Okay, so this is MB. So let me take this out and then put it here. Okay, 512 MI memory, and the default request it can take it as 256 when it is starting. Okay, so I have done that. Now the next thing is CPU, and the CPU I am going to use here is like 300 M I will use for my initial whenever the container starts. Okay, and later I'll try to increase, means like its limit I am going to give it as maximum limit of the CPU in this namespace this respective container is going to use is 500 M, which is 0.5 core of a CPU. So that's about the limit range manifest. But few things which we need to understand here is, if we don't specify the CPU here, right, so then automatically the default maximum limit per container whenever you are using the limit range Kubernetes is going to assign is 1 vCPU. So that is the thing. In the same way, if you don't assign the memory here, means like these two things are not defined under this default, right? So what happens is like it is going to assign 512 MI as the, means like 512 MB as the default memory for my respective container when we apply this limit range in that namespace. In the same way, so now if it is CPU or memory, if you don't specify this default request, so this is dangerous one. Okay, so if you don't specify this default request, automatically these containers whatever is under this namespace are going to consider this maximum limit whatever you have defined here as their even the request limit. Okay, so that's the thing. So if you don't define these things, then it takes these as the values for this one also. So that's the story about limit range additional stuff here. Okay, so we have created this one, and then let's also complete our other spec update stuff, which is nothing but all these manifest update stuff. Okay, so now let's go ahead and take the namespace value from here, copy it, and then update in metadata section of all these sections. Okay, so I'll come from Kubernetes secrets from down, so I'll copy here namespace dev3. So this secrets is going to get created in namespace dev3. Same way I'll do the same for our user management service, and then I'll do the same for our user management deployment in metadata section. After name in the same level we are giving namespace dev3. So for cluster IP service, so we are going to do that, and for MySQL deployment also enter, go to home and then copy. So and user management config map also under metadata section we are going to do that. And in persistent volume claim, yes, it is a storage, it is a namespace level object, we are going to create it, which we have discussed in our previous section itself when we are doing namespaces imperative. And one more we have, which is storage class. Storage class is not namespace level object. We really don't need to update. So we have updated from 02 to 08 all the objects with namespace as dev3. So now if you go ahead and then just say kubectl apply-f and then automatically it should get created. Okay. So now we have completed step 1, creating namespace, creating limit range, and then updating all k8 manifests. So in our next lecture, we'll create the objects and then test, and then also we'll go ahead and then clean up the stuff. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. So in this lecture, we are going to create the Kubernetes objects and then test it, and also go ahead and then clean up the stuff. So as usual, now we are going to create the stuff. Okay, so in 0502 you can see you have the kube manifest folder, and then inside that you have all the files with 00 namespace, limit range added now. Okay, so let's come back and be in 0502 and I will say kubectl apply-f kube manifest. Okay, so now you really don't need to give -dev3 or something. Why? Because -n dev3 is not needed, because we hard coded our namespace information in all the templates. Okay, so I'll say apply. So it should create the namespace, and then it should create the limit range, and then it created the storage class, persistent volume claim, config map, deployment, services, and user management microservice deployment, and then its equivalent service, and also the secrets required for those things. Okay, so now let's go ahead and then verify the stuff. Okay, so kubectl get pods -n dev3, which is nothing but in dev3, and then keep watching it, okay, till those things are completed. So now MySQL is up and running, right? So which means MySQL pod is done, and then finally initialization means like it verifies for the MySQL is up or not, that container has run and then completed, and then user management microservice also got created. Okay, so finally MySQL is ready, and then user management is also running, and then it is waiting for its liveness, and then readiness probe checks are going to happen for 60 seconds. It is going to wait, right? So there it is waiting currently. We can see here after 90 seconds even the user management microservice is up and running here. Okay, so now let me say Control C, clear kubectl get pods -n dev3 directly, and all should be running now. Okay, MySQL is running, and then user management is running, no restarts, everything worked as expected. So now we need to go ahead and then view the YAML output of these things. Okay, so for that you are going to say kubectl get pod and the pod name, and then -o YAML, and then -n dev3 namespace. Okay, so let's go ahead and then do that. Kubectl get pods, okay, and then get pod, okay, and provide the pod name, which is nothing but MySQL, right, and -o YAML, and where this pod is located is dev3. So now you will get the YAML output of it. So now we are getting we got the MySQL YAML output. Okay, so let's go up, go up, go up. So now you can see for the MySQL also you have the resources defined by default for this MySQL container. So in its spec you can see this is the MySQL container, right? So all this name in namespace dev3, you can see resource information for that is also added in the container spec definition. Okay, so in the container this is the spec, and then containers you have the environment, you have the image pull policy, name of your container MySQL, and the ports you have, and resources section automatically added whenever you added the limit range. So which means you have two containers inside that you have verified for MySQL. You can also verify the same thing for other things. Okay, so kubectl get pods -n dev3 and kubectl get pod, and then the pod name is this one, and I'm going to say -o, and then I need the YAML output, and it is present in namespace dev3, right? So now again go up, go up, go up, 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 up. See, now if you see here, so this is the image. Okay, so where is it? Okay, so you can see the resources section for initialization DB also it has added these things. Okay, so now let's come down and also verify for our other container too. Okay, so it has terminated, and where about our user management container? Okay, so it is the user management container. See, we said it is per container. So in this we are going to run two containers, right? So one is initialization container, which will wait for our respective DB to up, and for that it associated the resources, which is nothing but the init DB container. And also for the user management container, this is the user management container, and you can see health status and all this stuff. See, this is the name of the user management REST app container, and for that also you can see resources are associated. So this tells that whenever we associate the limit range for the namespace, all the containers present inside that namespace are going to get the default limits whatever we have defined here. So these are the limits we have defined, and all those things are going to get for our all the containers present inside that namespace. So let's also see little bit about these limits, means like get and then describe the limits. Okay, so let me clear this kubectl get limits -n dev3. So we have the limit, this is the limit name. So let's describe this limit, kubectl describe limit and the limit name. Okay, so this is the limit name. Let me paste it here, and -n dev3. So let's see what it is. Okay, what happened? Doesn't have a resource type limit, so it should be limits, right? So slight mistake I have done here, it should be limits. Okay, so now you can see here the container CPU and then container memory, right? So default is 300 M and then 256 MI, and default limit also whatever is there for this limit it is trying to show here. So whatever we have defined the spec, we are seeing in a visual manner whatever we have defined it. So in addition to that, now if you want to test it, so we can access kubectl, okay, get svc, which is nothing but services, in my -n dev3, which is nothing but in dev3 namespace. So 3002 is my port. Okay, so I need to go here and then update the port as 3002 and /. Okay, and then if I say enter, ideally it should come up. Okay, so it's coming up. Okay, with 3002 it is coming. If we want, we can even take the new tab and then paste it, and then we'll get the response. Okay, so refreshed it and then we are getting it. Okay, so now we have even tested it, right? So now for cleanup, as usual, if you want to delete your namespace, you can delete it and then delete storage class, or if you want, you can delete via manifest. Okay, I'll say kubectl delete -f cube manifest. With single command it will be done. So my namespace is deleted, limit range, all the objects whatever is present here are going to get deleted. So in our next lecture we'll focus on the resource quota concept. So I'll see you in the next lecture. Until then, bye bye. Thank you. Welcome back. In this lecture, we are going to understand about one more Kubernetes concept called resource quota in combination with namespaces. Combination in the sense how you can define the resource quota per namespace. So that's what we are going to learn. So let's take, like, we have a namespace named dev, and then we have our front end and then back end deployments and then everything inside that. So for this respective namespace, we can allocate a resource quota, like how much CPU should be allocated for this namespace, or how much memory it need to be allocated. So which means this namespace, the resources present inside this namespace, the containers or the pods running inside this namespace cannot use more than whatever is defined CPU or memory. In the same way, you can even define other services like pods or services or config maps or other stuff, like we can define in such a way that we can have only 5 pods running in this namespace. Anything other than that, it should not run. So like that, we can limit the number of resources to specific namespace using resource quota. So in the QA or in staging, everywhere you can define these resource quotas. So this is the sample manifest of the resource quota. So the kind, it is going to be resource quota, and the metadata name is ns-resource-quota, and the namespace it belongs to is a dev3 namespace. And in spec you can see that it starts with the hard, means like the hard limits whatever we are going to define for those resources in specific to that respective namespace. Like number of pods should be 5 pods. So if you try to run more than 5 pods, those are not going to schedule on this respective namespace. So I have running like 2 pods now, and if I try to scale any of this like front end or back end to another 10 pods, so it is not going to take in place when the resource quota is defined to be 5, even though it takes and then takes the request from us, but it will not schedule those pods inside this namespace. So which means it is invalid. So maximum it is going to have is only 5 pods whenever we do that also. So in the same way, we can even define 5 config maps or how much we want. Okay, so for this namespace, how many I want to define the resources, that many we can define config maps or persistent volume claims or secrets or services or whatever it is. Okay, even the CPU memory, requested CPU memory or limited CPU memory, limits.cpu or request.cpu, whatever we want, we can define in a orderly manner in the resource quota. So now let's go back to our GitHub repo, and we'll go to 050503 resource quota. And if you see here, as usual, we already created the namespace earlier. The same content from previous thing, we are going to copy it here. So, and then in addition to limit range, we are going to add additional stuff. So we have the namespace here. So we have the limit range here, whatever we had defined in our limit range section in 050502. Now we are going to add the resource quota stuff, whatever we have seen in our presentation. So we are not going to live template write this. Why? Because we already written a lot of live templates. So just like it's already we discussed about it, it is going to be a kind of resource quota, and in spec under hard we are going to have all these items, whatever we want to add it. Okay, so we added these things. So now we'll go ahead and then test it now. Okay, so we added, now we can go ahead and then create and then test it. Okay, so I'm going to say 05-05-03 and kubectl apply -f and then kube manifest. So this is going to create everything in dev3, the following things. Okay, so including the resource quota stuff, everything got created. So now if we want to verify the pod, CPU and memory, which we have done in earlier sections, we can ignore. And limits also we have seen earlier, we really don't need to worry. So we'll start with the quotas. Okay, so before that we'll say kubectl get pods and then -dev3. So just to see that our things are starting up. Okay, so they are starting up. So now let's go ahead and then view the quota information. Okay, so kubectl get quota -n dev3. Dev3 is our namespace. So ns resource quota got created. So now let's copy this and then describe it. Okay, kubectl describe quota, and the quota name is ns resource quota, and in namespace -n dev3, right? So now you can see it here. How many config maps used is 1 config map used out of our hard limit 5 config maps. So limit CPU, I have used 1 vCPU here out of 2. Okay, means like for the limit, how much limit is there. So limits memory 1 GI and the hard limit is 2 GI. In the same way, persistent volume claims, we have created 1 MySQL database with EBS as the volume. So it is going to be 1, and then out of 5 we have used 1. In the same way, we have 2 pods here, 2 out of 5. So like this, whatever we have defined, everything, right? So means like the hard limit and then how much we have used, we can see using kubectl describe quota. In the same way, if you want to go ahead and then access our application, you can say kubectl and then get our service port, and then also get the public IP and then access it. So this we are doing from longer time, so I will leave it to you. And finally, we'll go ahead and then clean up the stuff. Okay, so that's about Kubernetes resource quotas. So in our next lecture, we'll start with one more important concept, wherein why we should not use this EBS driver with MySQL. Instead of that, why we should use RDS. All those things we are going to learn in our next dedicated section for RDS databases and then Kubernetes. As part of that, again, one more thing we are going to learn is from inside Kubernetes cluster, how we are going to access external services. Okay, using external name service also we are going to look into. So I'll see you in the next lecture. Until then, bye bye. Thank you.